Alrighty, so if you can go ahead and put your Penn State ID into the chat box for me, that would be great. Welcome back from Thanksgiving break. I hope everyone had a great break. And we're going to go ahead and do chi-squared test again. So for lesson 11, we're going to go ahead and do this. And this is a pretty quick lesson. So let's go ahead and start with one of the main ideas that kind of surrounds goodness of fit tests. So we do have basically the whole idea of a goodness of fit test is to decide if we're comparing the groups and they're independent and then their proportions, so categorical, and then it's basically, so we're comparing one categorical variable and then more than two independent groups. So within that categorical variable, like that overall category that we have two different groups within that. And then we're comparing them to see basically, you know, how they relate to each other. And then this last bullet here just says test that the proportions are all equal to one another, or we can test any specific set. Basically, that's saying that, you know, if you have a bunch of proportions, you can just test a specific set of them. But if not, you can obviously go ahead and test all of them if that is something that's logical in that aspect. So yeah, and then we have expected counts, and basically expected counts are just talking about what we do in terms of trying to find a long run average. If we were to keep taking samples over and over and over again, what do we expect to find here? So basically the main idea for this is that if we take our sample size times the probability, or times our hypothesized proportion, and then however many that ith is just saying, you know, how many, which group number it is. So we go ahead and take that, multiply, and then that's going to kind of give you that long run average that we would expect to get if we kept taking samples over and over and over again. And we'll go into this a little bit later, but we do have to have an expected count of at least 5. To remember when we talked about, you want to make sure that if you're approximating something using the normal distribution, then in that case there has to be certain conditions that are met. So in this case for chi-squared test, we do have to have that it has to be met in the way that our hypothesis tests, or that our expected counts have to be at least 5 to go ahead on with that. And then for our test statistic for goodness of fit tests, it's a little bit different than what we've been going over. So we do have chi-squared is our test statistic for goodness of fit test. And this is just saying here, this is, this is saying the sum, and then basically you would go ahead through and do your observed minus expected squared divided by your expected, and this is going to be for each observation that you get. So remember when we, let's say, you know, this is our line, our goodness of fit line, you know, so this is going to be our expected value for, let's say, for this point here, but then, you know, our observed may be out here. So our observed isn't always going to be on the line, so that's just why this is where we're trying to find the chi-squared test statistics, because it's kind of finding that average between, you know, what our observed value was and then our expected, and, you know, we're basically using all the information from these to kind of find an average between, you know, how far apart they were. It's kind of similar to residuals, if you remember talking about that. So same idea there. Okay, so now let's walk through the steps for if we're doing an actual chi-squared test of independence, and you know, the different 5 steps for a hypothesis test here. So our first step, remember, we have to make sure that the conditions are met, and then we're going to go ahead and write our null and alternative hypotheses. So our conditions that have to be met, as I mentioned earlier, is that we do have to have our expected values have to be at least 5. So remember, our sample size times our proportion. I cannot. This is sad. That's an N. I'll just, okay, sample size times the proportion has to be at least 5. That's what our expected value is. And then also has to be randomly drawn in order for us to, you know, assume that's going to be representative of that population. And then if these conditions are met, we can go ahead through and write our null and alternative hypotheses. So our null is going to say that there's no relationship between them, therefore they are independent. And the alternative is saying that there's some sort of relationship. So if they would be dependent, that means that one affects the other, meaning that there is a relationship there. So that's the main idea for writing out those null and alternative hypotheses for a chi-squared test. And then, oh, send help. Meow, meow. All right, this isn't working, but we'll just, okay, how about this? Okay, Oh yeah, all right, cool. All right, so our second step for our chi-squared test of independence, so our hypothesis test basically for a chi-squared test is going to be our test statistic, remember? And this is just a little bit of a review that we talked about earlier, how to find that test statistic, which is our chi-squared, and then our expected value in terms of our cell value. So this one's a little bit different because we're talking about a cell within our list and our rows and whatnot of the different values we got. So instead of taking like observed minus expected, that kind of thing, we are going to use the totals of our rows in our column and then the total sample size. So that's a little bit different here, but this is basically just showing you here how to find that expected value here if you're not already given it. So yeah, and then just a reminder that our test statistic is what we use to test for a statistically significant relationship between those two categorical variables. And that's basically the main idea there, that we're going to use whatever value we get in order to test for that statistical significance, which is our third step. Basically, we're going to find that, determine what our p-value is. And remember we talked about degrees of freedom before in terms of being n-1. But we did have, in this case, since we're talking about rows and columns, because we have a little bit different of a setup for a chi-squared test, we are going to have our degrees of freedom be number of rows minus 1 times our number of columns minus 1, just ensuring that all of those are taken into account in this case. And then lastly, in our last two steps are always the same. Based upon that p-value, we're going to go ahead and make a decision, either reject or fail to reject or null. I hope you guys kind of understand these two steps by now. We've talked about them a lot. And then step 5, just state that real world conclusion based upon the context of our original question. Instead of just saying that we fail to reject, whatever, that we kind of talked about what that actually means in terms of what our original question was asking us. Okay, and then one more thing, we do have relative risk in this chapter. Just this is similar to probability. So you might kind of recall it from that chapter. But it's basically talking about, we want to talk about like the difference between statistical significance and practical significance. So this is kind of like our step 5 of our hypothesis test, where we're finding our real world conclusion. It's going to show you more practical significance in this case. So our p-value, remember, gives you statistical significance. So you're either going to reject or fail to reject, reject or null. And then that's what our statistical significance is. But then relative risk is going to be comparing the risk of a particular outcome in 2 different groups here. So this relates to chi-squared tests because, remember, those are comparing the 2 independent groups within a categorical variable. So in this case, it's basically talking about the risk between the 2. So it's giving, and like basically after you get it, it's saying like the risk of group 1 as a multiple of the risk of group 2 in that case. And then this is just the equation that you would use to find it. So remember, risk is basically the same thing as the probability of something happening. So this is basically saying the risk of group 1 happening divided by the risk of group 2. And then that's basically going to be able to give you that relative risk in the end in that case. Alrighty. All right, cool. Let's do some review questions. Like I said, it's a pretty short chapter. So let's try these out. So the table above summarizes by biological respondent the responses from 1,033 adults to the question, do you smoke? What is the relative risk for female smoking compared to male smoking? So this is the last thing we just talked about since it's fresh in your mind. So go ahead, try to solve this one, and then we will go over it together. Yay! Great job, guys. Yeah, absolutely. So our answer is going to be B here. So if we look at it in separate parts, so remember our relative risk, we want to find the risk of each separate group first. So our risk in group 1 would be our basically the females who say yes divided by that total number of females. So we're going to have that 171 and then that 589. That's going to be our risk there. So our risk of 1, you can't see that, send help. All right, so risk of group 1 is going to be 171 divided by 589. And then if we go back here and we're trying to find, then we need our risk of group 2. That's going to have our 142, so the number of males saying yes divided by our total number of males, 444. So then our risk of group 2 is going to be 142 divided by 444. And then if we go ahead and do all of this together, basically what we're going to get is 171 divided by 589, and then divided by 142, so our risk in group 2 divided by 444. And then after we solve this out, we're going to get about 0.908, which is our answer for B. So good. So remember, this is our risk in group 1, and then this is our risk in group 2 here. So our answer is B. So good job. Way to go. Raise the roof. All right, I said it again. All right, let's try this one. All right, so when conducting a chi-squared test on 2 variables, a statistically significant relationship is illustrated when what? So go ahead, read through these answers, and then we will go over it together. All right, good job. Yeah, our answer is D here. So remember, when we're talking about statistical significance, we want to show that there's a large relationship, because remember, our null hypothesis in chi-squared is saying that there's no relationship. So then, not really sure what word I was trying to write there. Let's just try that one again. Clearly, I'm not back from break yet. Here I am. Okay, relationship. So, and then in this case, so that's saying we have no relationship. So then remember, if it's statistically significant, then we're going to reject the null. So that's saying that there is a relationship. Wow, I did it again. Send help. All right, so then in that case, there is a relationship. So we do want to have a large relationship in order for it to be statistically significant. So that's why A and B wouldn't be correct. And then the reason for the last part of it where it says likely to occur if there's no difference in the population, you want to make sure that it's talking about, so unlikely to have occurred, because this is basically saying that it wasn't due to chance. This didn't just like kind of happen, you know, by chance because there is no difference in the population. It just happened by accident. This is saying that we're pretty confident that there is actually a difference in the population. So we're able to make this statistical significant conclusion here in this case. So yeah, okay, good job. Yes, our answer is D there. Yay. All right. All right, another research question. So is there a relationship between whether or not someone likes chocolate cupcakes or whether or not they like chocolate milk? Definitely a relationship. No, I'm just kidding. I don't know. Okay, a sample of 200 participants is obtained. Each person is asked if they like chocolate cupcakes, yes or no, and if they like chocolate milk, yes or no. So which of the following statistical analysis should we use to analyze these data? So this is kind of going off the idea of, you know, what kind of tests would you use based upon the different, types of samples we have and the different, yeah. All right, try this one. Maria is on this. She knows this one. A+. Ooh. Yay, good job. Yeah, so our answer is B here. What a surprise, because we're talking about chi-square tests. But it's just, to kind of understand why we would do that. So in this case, we are, remember, talking about categorical variables. Wow, not sure how my pen got so large. Okay, so we have categorical variables, so we know that it can't be C or D because these are talking about means. So this will be for quantitative variables. So we know it has to be A or B. And then in this case, we do have 2 independent groups, because we have basically they're saying yes or no, so that's why it's categorical to either chocolate cupcakes and then for chocolate milk, so they are independent. So we definitely have 2 groups here, so it definitely wouldn't be a 1 proportion z-test. So then in that basically our only other option would be a chi-square test of independence. So that is our answer. Good job. You guys are doing great. All right, one more. All right, the table above shows the opinions of 953 respondents in the general social survey to the question, do you approve or disapprove of wiretapping? The purpose of the research is to examine the relationship between biological sex and approval of wiretapping. What is the correct alternative hypothesis for this research study? So try this one out and let me know what you think. Yes, good job. Good catch. So remember, when we're writing hypotheses, our null and our alternative, wow, what is going on? Our null and our alternative are both in terms of our population. So that's why D can't be correct, and also B can't be correct because they're talking about in the sample. So that's not true. And then let me see if this might be better. Okay, and then remember, our alternative hypothesis is saying that there is a relationship going on. So that's why C has to be the correct answer. Now it's too small. A can't be correct because they're talking about there being no relationship, which is would basically be our null hypothesis here. So our final answer would be C there. So good job. Yay. All right. Oh. All right, that's all we got. Like I said, pretty short chapter because we're winding down the semester. So definitely start studying for the final. I would recommend. Don't wait till last minute. Unless you want to. Unless you want to, just cry. But I think you guys will do great. You guys have been up on it the whole semester. So our next review will be on Thursday, I think. Probably. If not, they'll tell you. But yeah, our next review will be for our last chapter, maybe. Actually, I don't know. I don't know why I said that. Who knows? It's for our next chapter, maybe our last. But yeah, so I think everyone gave me their Penn State email. If you can go ahead and do that, thank you. Thanks so much, Lan. Appreciate it. And yeah, let me know if you have any other questions for this chapter or anything in general. If not, have a great week.